Okay. Do another vid on this tremolo circuit and maybe explain some of the details. As I've said, there are other videos. I have not yet linked to them, but I will do so, that explain this in much greater detail, the theory of operation and so forth. I feel no need to duplicate that fellow's work, but to simply describe what, more closely what the component values I'm using are, just experimentally. They seem to work very, very well so far. So again, this is not rocket science. Simple phase shift oscillator. I don't know if this is going to show up very clearly here, but so I'll walk through it. The supply to this is 300 to 400 volts DC positive going in. Doesn't matter a whole lot with this. It's not critical. I usually tap into somewhere between, and I think here I've got 360 volts. I'll measure it later. I have measured it, I just do not recall the exact number off the top of my head. B plus going through all of the B plus here that's consumed, that current has to pass through this. So as this thing wobbles, this changes in brightness, up, down, up, down. 100K resistor, I think not critical. Put 200 in there. Just something to limit the current through the plate and this neon bulb. The neon, tiny thing. The tube, I'm only showing half of it. It's a 12AX7A. The plate, there's two triodes in that thing. They're identical, but for their pinouts. Pin 1 is the plate I'm using. Pin 2 is the control grid. Pin 3 is the cathode. As with all these 9 pins, 12 volt ones. Pin 9, one side of the 6.3 volts AC heater supply, and both pins 4 and 5 tied together go to the other side. So that supplies the heater for the unwashed. Cathode resistor is 4.7K. All these resistors are something like an eighth watt or a quarter watt. It's, you don't have to worry about that with this circuit. Very little current flows through it. This capacitor, I put a 33 microfarad, happens to be rated at 50 volts. This could be rated at 20 volts and be fine. The value, I put a 33 in. It could be 22, it could be 47. It really doesn't, it's not critical. I split the difference, I put a 33 in there. Plus I had one handy laying here on the table. This filter network. The first capacitor, that's a 0.02 microfarad, this one here. That one needs to be able to withstand a few hundred volts on this plate, which is wobbling. But that does need to be rated for a higher voltage. This 0.02 microfarad. These two are both 0.01 microfarad, 0.01 microfarad. The ones I have tied in here are probably rated at 50 volts or so. And that'll probably be just fine, but when I make this more permanent, and I am going to do that in a couple of places, I'm going to use higher voltage than 50, just in case. It's to convention to do that. Even though they'll probably never see that, who knows? I could measure it, but who cares? I'm just going to go with probably 400 volt caps all throughout. once I make this more permanent. This is a 1 meg resistor. This is a 1 meg resistor. Not critical. We go up a little, down a little. It's not going to matter. You would want these to be pretty much the same. These two caps and these two resistors to get the proper phase shift. You know, play around with it if you want, and you might get a different contour of sine wave through current through this neon, which kind of will affect the response that the rest of the circuit will have. This is just the oscillator, and its output is this neon lamp. This resistor is 100K in series with a 2.2 megohm pot. I want this, it works okay the way it is. With these values here, of course this adjusts the oscillation period, the frequency of oscillation. I used this 2.2 meg because that was handy, it's Tremolo. I'm going to use a panel mounted control in place of it, and when I do, I'm probably going to raise this to a higher value so that I can get this thing to oscillate at a slower rate. At the same time, I'm going to decrease this value here, this 100K, so that when this is set to minimum resistance, you get a bit of a higher oscillation rate, a shorter period, higher frequency out of it, of modulation. That's really simple stuff. For testing purposes here, I'll just leave it what it is, but once installed, those are going to change. This will probably be, maybe 50K, 80K, something like that. And depending on what I have in my stash, I may have to buy one. Probably going to want this to be 3 meg or 3.5 meg, maybe even higher than that. With this network, I don't know how low it'll go, and there is a certain point where it's just kind of useless for a musical instrument amplifier. So there's that. So I guess we're done with this. This neon, as I've mentioned in a previous vid, the light from that, it's opto-coupled to a photoresistor. Put that up here. A little bit of detail on that. There's the neon. I'm using an NE2H. You could use just about any small miniature neon like these guys. It's not critical. I've played around with different ones. I'm currently using are A9A/NE2E, made by Chicago Miniature. These are doped, so they have a slightly lower firing voltage, which is desirable here. But it's not crucial, don't worry about it. The photocell, that's an optical contact, not electrical, but optical contact, optically coupled. This dotted line around here just illustrates, hopefully, that this has to be shielded from light. You don't want incident light impinging upon this resistor because it messes things up. This might also benefit, there might be some benefit if the light shield were also a electrical shield. In other words, better if that's metal. I just, for this setup, I just used a piece of shrink wrap. And depending on where it is in the chassis, it may be superfluous to make the metal shield out of this, but nevertheless, this does need to be light shielded, or something opaque to block the light from getting to this, other than from this neon. There's not a whole lot of brightness from this, but it's enough if the photocell's connected appropriately into the amplifier. Describe this photoresistor. I said all that. The type of photoresistor I'm using, if it matters, is CL-705HL. Quite sensitive. The resistance change from complete darkness to even a tiny bit of light is quite remarkable. I've measured it, and it varies so much from one device to the next. I'll leave it up to someone else to look up the specs. I don't recall them off the top of my head. They are sensitive enough to the wavelength of light that these neons put out that it will work just fine. And if it doesn't, there are other things you can do to change that. There's a capacitor here and a variable resistor. The value of these two is going to depend. When I mean value, I don't mean voltage of this capacitor. I mean the capacitance of this cap and the resistance of this resistor are gonna be. You're gonna have to do it experimentally. With this capacitor, I've gone from 10 microfarad all the way down to 0.001 microfarad, depending on which amp I'm tying it to and where I'm tying it. And yeah, it's one of those things you have to kind of do it experimentally. In this particular case, the caps I'm using, I'm selecting between, what is this? 472, so that's a 0.047. Am I getting that right? Yes, this one's 224, it's 0.22. So, oh no, 0.0047. I'm sorry, this guy. So, it could be all over the map. I put this capacitor here only to do DC blocking. Let enough of the low frequency modulation come through this capacitor to change the grid voltage on whatever to. Now, this resistor, it's going to depend too. That's going to be the intensity control, the amount of modulation. I want it to go from practically zero to full modulation. And when I say full, I mean it cuts off on the down slope. When this thing gets minimum resistance, the most light, basically it momentarily at least grounds whatever grid we're tied to. In the previous vid, I had attached this to a Motorola phonograph amplifier, and the grid I was tied to, the grid this was tied to was the control grid for the phase splitter. The furthest tube down the line, the furthest active element down the line before you get to the output tubes. It was very, very effective. So I'm going to build an outboard circuit for that. I'll probably use these components for that one. But what I want to get into now is this Duquesne amplifier, which I've described in a different video somewhat. I did some repair work on it. Let me, before I go much further with this, see if I can get a good image of that schematic. Ooh, I know that's a bit small, but it's all I got to work with right now. This is a schematic drawing for this Duquesne 460A, or yeah, Duquesne, oh good lord, 460AU, 460UA, something like that. Good lord, it's probably written down. Oh, there it is. Okay. 1U460A. And there are different suffixes to that you know, they were different options on these things. Kind of shows that in the schematic, and I don't know how much you're going to be able to see here. Very kind of them to paste the schematic on the bottom cover, complete with the part list, and everything else you need to know, except theory. On the Motorola amplifier, you know, in this amp, these are the outputs. They're 5881s. Think hyperactive 6L6s. On the Motorola amp, I attached this modulation directly to the grid of the phase inverter for the output tubes, directly to that grid. Which, in that case, though, the output tubes are 66s. The phase inverter is a 12AU7. In this case, again, these are 5881 6L6s on steroids, and this is also a 12AU7. I'm sorry, 12AU7. At first, I did try the same trick. I just tied it right to this grid. No, nothing doing. Impedance is too low on this part of the circuit. Probably in fact, surely because this grid connects directly to this plate, and the impedance between this plate and ground here is just too low. It did modulate, but it was weak. I did consider using the other half of the modulator in this circuit that's not currently being used. Maybe make a cathode follower to increase the brightness of the neon. Why do all that? I want to have that spare triode for something I'm going to attempt later on. So I moved back a stage, tied to this grid, an improvement, but still the modulation the depth of it was just not satisfactory without doing any modifications on the oscillator circuit. So I moved back one more stage, and that's definitely adequate. This tube here is just it's part of the tone stack, the tone amplifier involved with that. So in addition to giving a amplitude modulation, it does do a very slight, detectable, at least by my hearing, a tone modulation. Sort of like a wah-wah pedal would do. Not quite as pronounced as that, but you get the idea. It's not unpleasant at all, and I think that's where I am going to keep it. I had gone back to a previous stage, and there was no material gain by doing that. I don't mean increase in gain, but there was nothing gained by going further out. In fact, the further toward the front end you go, the more likely it is that your circuit's going to introduce clicking and noises and hums and stuff. So the closer you can get to the output tubes, the better with this. But it has to work, and so work your way back through these grids. Do check your current limiting resistor for, you know, whatever the impedance connected to that grid is. You have to be aware of that, and that you're going to be grounding it. I doubt very seriously if any one of these grids is going to be sitting at B+. So it's pretty safe. Just make sure you're on the right pin for the grids of these tubes, and back your way up until you find the grid that, you know, with full coupling, and it gives you a nice deep tremolo effect. And then you can add a potentiometer and play around with the coupling capacitors in there to trim that. Eventually, you would want to have, you know, a panel mount or top mount or somewhere a control to change the depth from very mild to severe. I will demonstrate some of that later with this. I kind of have to hurry a little because I don't want this to be more than half of an hour. There, so I hope that schematic showed some, at least enough. They are available online. 1U460A, made by Duquesne. You'll find it. Geez, I would like this. Go back. I'm going to stop this a sec. Okay. I don't know why, for some reason, my camera's zoom out function sort of locked up on me. Not the first time that's happened. Okay, so again, here's the oscillator, tremolo oscillator circuit. It's optocoupler. Let's see, it's all tapped in. This being tacked into a random tube socket for the heater supply, 6.3 volts. This tacked in to ground and high voltage DC, which I will measure for you, just to make sure. The oscillator's output is coupled through this 0047 mic capacitor. This one's rated, gosh, it's not marked, but it's got agency approval marks on it, so this is probably 600 volts or thereabouts. Yeah, these are AC volt rated. That's why they have the agency approval, recognized UL, CSA, and others. Yeah, so this is rated 125 volts AC, so that's a safety cap. It don't matter. Signal doesn't pass through it; it gets shunted by it. So who cares? You don't need vitamin Qs for that. So, oh, and this is where the output from the oscillator is tapping in. And I worked my way back. These are the output tubes. They're coupling caps to the phase inverter, and I worked my way back grids of these two sections and the grids of these two sections, and where I've landed is the first section of this, which is involved with the tone stack, volume control and tone stack. This doesn't have a master volume, by the by. It only has separate input volumes, which this has 5. 3 microphone inputs, 1, 2, 3, and 2 auxiliary inputs that are line level. You plug in tape recorder outputs and that kind of thing. This I mostly use as a guitar amp. Like I said, it has 3 microphone channels. I'm only using 1 channel, and that's where I plug in. So the tubes for this section and this section aren't even in place. The only one for these 3 channels is down here. Now I'm poking my fingers in here. It's plugged in but turned off. The line voltage stuff is on that end. I'm not putting my fingers anywhere near that at the moment. You do have to be cautious of that. So, well, what does this thing do? Let's go ahead and give it some juice. See the pilot lights coming up. And let things warm up. Volume down. You might hear some popping. That is the extreme action of this oscillator into where I've attached it. Now this amp is as quiet as a church mouse as it is right now. You could get some hum when the input is just kind of floating here. A 1/4-inch phone plug for plugging into the guitar. And just attaching that, I've got 100 miles of pickup here, so it's no wonder that's humming like that. and that hum is being modulated by the oscillator. It just farted. So anyway, that's what that's about. Once this is cleaned up and put under the hood without clip bleeds and stuff, that all that hum and buzz will be gone. The clicking, I don't care about that. At this extreme level of modulation, that's not going to be noticeable, really. And give it a little volume. I do have to be careful with my handle here. Slower. So that's with a fairly small coupling capacitor, the low 47. This is a 0.22 microfarad. It's gonna deepen the tremolo a bit. So you do have to play with that capacitor value, that coupling, even if you're using it. You don't have to. I do, for reasons I've already explained. It's very sort of it's probably difficult to pick up with this camera's microphone, if you can call it a microphone. But it's liquidy. It is shifting the tone response of the circuit a little bit, enough to detect wow wow instead of whoop whoop whoop. It's kind of cool. Which of course is also influenced by the bass and treble controls on this thing, because of where this modulator is tapped in. Yeah, that's pretty full depth modulation. I'm going to insert what is this, 47K resistors in series with this tap and this capacitor. And it definitely lessens the depth of modulation. So, simple matter to just put a pot in place of this. Pick a value that when it's set to maximum resistance, modulation is either gone or not noticeable. And the minimum resistance gives you the full Monty. Oh, I keep touching this. Gotta be careful, this guitar's grounded, and this, well, this is actually close to ground, this pot, but there's high voltage there. Same riff I was doing with the, I guess for a comparison, if you want, the Motorola amp. there's no way I know this this camera's going to pick up the dynamic range of this. Turn the amp off, drop the X, and so what are my plans? Well, with this, I've got 15 of these amplifiers, and they're all working. This one, of all of this, the only one I really had to do some repair work on. It's really not major at that. I've replaced these. This capacitor's orange one under here. This is turned off, so we're good. For now, I'll just leave that hooked. So, what are the plans? I'm gonna put this down. Okay, not crushing anything. Things are very heavy. Let's see. I'm gonna swing this around. Sorry about that. As I said, these Ducanes, they had different options depending on which model you bought. This one, and it had mostly to do with how many microphone inputs and how many aux inputs it had. The 1U460A had 3 microphone inputs, or if you like guitar inputs, lower high impedance depending on whether or not the microphone transformers or these jumpers were plugged into those, and 2 auxiliary line level channels, 5 channels. Some of these, rather than have 2 aux channels, they had 1 aux channel and 4 mic channels, and when they did that, there was another tube, a front end tube, sitting right here. And fortunately, the chassis is already punched for that. And what they did was they just put a cap in there, cover over the hole. Which means you got a handy place for a tube socket. Perfect place to put my vibrato tube, which not only will supply the vibrato function, but leaves me with a spare triode that I can use for something else I plan to do, or at least attempt with this. It would be a reverb. I've got a couple of reverb tanks laying about, spring reverb tanks laying about, and it'd be kind of cool to have some reverb integrated into this too. But for now, the tremolo. So there's a spot for the tube. I could, because I've got these 2 unused sockets here, just use one of those, or both, for other things, since I really only need 1 channel for my guitar. I don't share my amplifier with other players. It just won't do it, other than the PA. But since I got the hole here, got sockets, appropriate sockets and screws, and just put a new socket in there. I've done it before for indicator tubes and things with these amps. And here, it's probably a little difficult to see from this angle, there's a knockout that would accommodate an octal tube socket right here. It's just not punched through, it's not knocked out. What I'm going to do, I need a place to put a rate control and a depth control. I don't want to drill this chassis, but I don't have a problem drilling a knockout. I can drill that and put either a concentric gang pot or 2 small ones. I'll figure something out. At least I have to have a rate control to control the oscillations, the modulation. The depth control, not too terribly concerned about that. Maybe I'll rob one of these mic control pots and use it for that, since I'm not using it otherwise anyway. I'm not particularly picky about having everything on the front. I want to do as little modification of this as practical to get this to work. Like I said, this is number 15. She's, of them, the most hosed. Not the right word. She's been molested somewhat. These are not original capacitors. These are replacements, which is fine. They work. They're in very good shape. But they're not original. So this is my sacrificial lamb. If I did change its collectible worth some, I'm not especially worried. I've got it. I'm going to use it. So that's the plan. Oops. Bye-bye socket. I am going to, pardon me, play around a little bit more. Try some different pots for the rate and the rate control and the depth control, and see if I can arrive at something that, at least to my ears, is satisfactory, and go ahead and install it. And, maybe once I do that, I'll do a demo of it. I certainly will if I get into connecting a reverb tanks to this and the circuitry involved with it. I'll definitely add that on. A little bit torn. I did a previous video on the servicing of this amplifier. Now, should I make this number 2 of that video, or do I make this number 2 of the Tremolo video I did for the Motorola amplifier? I can't really do so much both unless I link. I'm just thinking out loud. So anyway, that's that so far. I am definitely, once I get this tube wired, socket wired and installed, I'll definitely do a demo. It's not going to sound a whole lot different, but it'll look prettier. See ya.